All right, so what does it mean to find the composition of functions? All right, and this is actually exactly what we did in our warm-up problem. Suppose you have two functions, f and g, and that the range of g is a subset of the domain of f. All that means is that the numbers you're getting out of g are numbers that you could have plugged into f, okay? Don't stress about that part about it too much. This is the important part. The composition f of g can be described by this equation down here. F of g of x is equal to f of g of x, okay? So this little symbol right here, this O, is read of, okay? And we already know that this is also f of g of x, okay? So we're going to use the functions 2x plus 3 and x squared minus 5 to evaluate these different expressions, all right? So to find f of g of 3, so looking down here, f of g of 3 on problem number 1, this is the same thing as saying find f of g of 3. And what that means is we want to find g of 3 and then plug it in. So I'm going to start with, what does g of 3 equal? So g of 3 is going to be coming from x squared minus 5. So I'm going to do 3 squared minus 5, which is 9 minus 5, or 4. Okay, so that 4 right there, this 4 is going to take the place of g of 3, and that's now going to give me, find f of 4. And finding f of 4 means I'm now doing 2 times 4 plus 3, because f of x is 2x plus 3. So that gives me 8 plus 3, which is 11. Final answer there is 11. So f of g of 3 is 11. So it's an inside-out process. You find the value from the inside, g of 3 first, and then you plug that into the f value, okay? So the range value, the y value we got out of the g of x function, the 4, gets plugged in as a domain value or an x value into the f, all right? So that's the domain range connection there. All right, let's take a look at number 2. On problem number 2, we want to do g of f of negative 5. So this is g of f of negative 5. So I need to find f of negative 5 first, which will be 2 times negative 5 plus 3. So that's a negative 10 plus 3 is negative 7. And now, to finish it off, I need to find g of negative 7. G of negative 7 is negative 7 quantity squared minus 5. So that's 49 minus 5, which comes out to 44. So that's my final answer for number 2. All right. Now, number 3 is a little bit more intense because it has an extra composition. This is g of f of negative 1. I need one more parenthesis. So I'm going to start with f of negative 1. And just in the interest of space here, I'm not going to write out every little detail. F of negative 1 is going to be negative 2 plus 3, which is positive 1. The next step is right here. I'm now going to work on g, the first g. All right, so that's going to be g of 1 is going to be equal to 1 squared is 1 minus 5. That comes out to negative 4. And now I'm going to take a look at doing this g out here. And that's going to give me g of the result I just got, negative 4. Negative 4 squared is 16. 16 minus 5 is 11 again. So all these answers happen to be multiples of 11. That was coincidental. All right, so that's how you evaluate a numeric composition. You plug the number into the rightmost function or the innermost function, and then you take that result, plug it into the next, and you just keep going until you've run out of functions to plug into.